Given three sets A, B, and C. Using these three sets, we need to obtain each of the following. Let us begin with the first one. So in the first problem, we need to obtain the Cartesian product of the set A with the union of B and C. Okay, fine. So let's first try to obtain B union C. So B union C is simply taking the elements that are common to B or C or both. So here we have the set B containing the elements 4, 5. This is going to be taken the union with, we'll take the union with the set C containing the elements 5, 6. So B union C is going to become 4, 5, and 6. Okay, so what we'll do, we'll take the set A containing the elements 2, 3. We'll try to find out its Cartesian product with the set B union C, which contains the elements 4, 5, and 6. Okay, so this is going to be, so what we'll do, we'll take the first element of the first set because A comes first. We'll take the first element, which is 2. We're going to form an ordered pair with each of the three elements 4, 5, and 6. So that's going to give us 2, 4. Then we have 2, 5. And then we have 2, 6. Followed by the second element of the set A, which is 3. 3 is going to be forming an ordered pair with the elements of B union C, 4, 5, and 6. So we're going to get 3, 4. Next we have 3, 5, and then we have 3, 6. Okay, fine. So this is the Cartesian product of the set A with B union C. Coming to the second part of the problem, now we need to find out the Cartesian product of the set A with B intersection C. So that means we have the set A containing the elements 2, 3. We're going to find out its Cartesian product with the set B intersection C. So let's obtain B intersection C as well. The B intersection C means consider the set B with the elements 4, 5. And its intersection with the C, 5 containing the elements 5, 6, simply means that we pick up the element that's common to both B as well as C. So that's going to be the element 5. So we'll find out its Cartesian product with the set containing the element 5. So now we have 2, 5, and then 3, 5. So this is going to be the Cartesian product of the set A with the set B intersection C. Now, coming to the third part of the problem, so here we'll have to find out the Cartesian product of A and B first, and then find its union with the Cartesian product of the set A and C. Okay, to do that, we'll have to find out the Cartesian product of A and B separately first. So let's find out the Cartesian product of A and B. Now here, A contains the elements 2, 3. So there are two elements. We'll have to find out its Cartesian product with the set B containing the elements 4, 5. So the procedure remains the same. Since A comes first, we are going to consider the first element of the set A, which is 2, and we're going to form an ordered pair with each of the two elements of the set B. So we get the ordered pairs 2, 4, and 2, 5. Next, we're going to consider the second element of the set A, which is 3, and form an ordered pair with the two elements of the second set, which is B. So we have 3, 4, and 3, 5. So this is going to be the Cartesian product of the set A and B. So that means now we have the ordered pair, the set containing the ordered pairs 2, 4, 2, 5. Next we have 3, 4, and 3, 5. We're going to find its union with this set, the Cartesian product of the set A and C. So let's find out the Cartesian product of A and C. So we'll consider the first element of the set A, which is 2, and form an ordered pair with each of the two elements of the set C. So we have 2, 5, and we have 2, 6. Fine. Next, we will consider the second element of the set A, which is 3. So 3 is going to form an ordered pair with each of the two elements of set C. So that's going to give us 3, 5, and then we have 3, 6. So now that we have the Cartesian product of the both of the two sets, we can easily find out their union. So we have the ordered pair 2, 4. Next, we have the ordered pair 2, 5, but that's common to both of the two Cartesian product, so we were going to consider only a single ordered pair. Next we have 3, 4. Next we have the ordered pair 3, 5. Now 3, 5 is also present in the next set. So we will consider only a single ordered pair. And we have the remaining ordered pairs 2, 6 from the second set and 3, 6 from the second set as well. So this is going to be the union between the two Cartesian product A and B and A and C.